Hello everyone, I'm here to present to you a project called an intelligent event registration system with face recognition using convolutional neural networks and by the author names Narageka Bridget, presented by Group E from Makerere University. So for the introduction, we're going to talk about a brief information about machine learning. Machine learning is a way for computers to learn from data and make decisions without being programmed for every specific task. So in this project, machine learning is going to be vital in the following ways. So it's going to help us in facial recognition accuracy, whereby CNN can, because you're going to use CNN, that's convolutional neural networks, that can analyze and learn intricate facial features with high accuracy. It will also help us in the reduction of human errors, where automating the registration process through machine learning reduces the likelihood of human error associated with manual check-ins. So, a brief information about some of the methods you're going to use or techniques. You can say how supervised learning. Here, supervised learning, a model is trained to use labeled data. So here, CNN model will be used for this project, especially for architectures like VGG and FastNet and so on. So for unsupervised learning, we have solved problems that can include facial recognition and attendance tracking. Someone can easily track your attendance by just knowing that your face appear there or not. And then labeled data will be utilized in things like data set creation, training process, and so on. And then unsupervised learning. And for unsupervised learning is where an algorithm is given data without explicit instructions or what to do with it. So K-means clustering will be used for this case in this project to divide the dataset into K clusters based on the similarities in the data points. So we have types of insights aimed to discover. These are going to include grouping similar faces, and this can help in grouping similar facial features without prior knowledge of the individual. So handling unlabeled data. In case of unlabeled data is being fed in, we're going to use unsupervised learning for that case. And then we have reinforcement learning. For reinforcement learning is a type of machine learning where an agent learns to make decisions by interacting with an environment. For this case, according to this project of an intelligent facial recognition, an intelligent event registration using facial recognition, an environment is going to be can be the overall event space where the registration system is deployed. And then you have an agent. An agent in this case, it can be the component that adapts the facial recognition parameters based on the environmental conditions. And then we have reward systems. A reward system is the one, this is the one that provides feedback to the agent after taking action. So we have user cases, can be crowd management, can manage a lot of people. Just facial, everyone just appears, and then that's how you can easily manage the crowd. Then error handling and recovery and so on. And then you're going to compare these techniques, the supervised, unsupervised, and reinforcement. So in the comparisons, we came out the solution. Supervised learning is well suited for tasks with clear input and output relations, such as facial recognition, unlike supervised learning that explores patterns and relationships in it. Okay, sorry for that inconvenience. Supervised learning is well suited for tasks with clear input output relationship, such as facial recognition, unlike unsupervised learning that explores patterns and relationships in that data without labeled information. And then supervised learning is also effective when labeled training data is available, and for supervised learning, it's applicable when structure of data is not well defined, aiding the clustering. So reinforcement is ideal for sequential decision-making problems. It allows for continuous improvement through feedback and adaptation. So based on that data, based on that data and problem statement. So based on that data, supervised learning is going to be preferred because it requires labeled data set, and in the case of facial recognition, Having a data set with labeled facial images in brackets can say identifying individuals in each image is also essential. Then unsupervised learning is also going to be preferred because it is valuable for exploratory data analysis. So techniques such as we talked of k-means clustering can help identify natural groupings or pattern within the data set. And then some of the challenges that are most likely to be faced or already being faced is acquiring a sufficiently large and diverse label data set for training the facial recognition model in the supervised learning can be time consuming and I think also resource intensive. And then overfitting. This could occur when a model learns to the training data too well, including noise, and performs poorly on new unseen data. Then you have extracting meaningful and interpretable insights from unsupervised techniques such as clustering can be challenging. And then for the considerations, we're going to consider privacy concerns. How privacy concerns like machine learning models can potentially intrude on individuals' privacy, especially in applications involving personal data such as facial recognition. And then we have sampling bias. Training data that does not represent the entire population can introduce biases. Whoever is trying to sample the data and trying to use it. And then data labeling bias, like biases in labeling process can propagate through the model, which is a good idea. And then in our conclusion, there are a number of technical moral issues that need to be taken into account when creating and implementing an intelligent event registration system with facial recognition using the CNN, because supervised learning can make use of labeled data, attain high accuracy, and adjust to particular event features. It is then recommended it is then the recommended approach for facial recognition. However, over the course of the project, carefully thought is required due to ethical considerations of biases and potential unforeseen repercussions in machine learning. And then lastly, we have our references. Thanks for listening.